Hello, this is Barry Evans with Penn State University. In this unit, we will view and edit some of the input data that we had generated for the GWLFE watershed simulation model using MapShed. Specifically, in terms of activities, we will first open the GWLFE model and then view some of the input data in one or more files that we had created previously using MapShed for one of the watersheds in the demo dataset area. We will then edit some of the input data, rerun the model, and view the changes to the output based on these edits. First, I will open up the MapShed project called Demo, and then I will access the GWLFE model using this button. And remember that we can access the model either through this interface or we can double click on the executable contained in the models folder under the run files folder, or actually under the MapShed folder. So once I open up the model, I can then load a file. In this case, I will open up the file that we had created for the watershed called 7238, which was under the demo single folder. So I'll click on the button, I'll browse for that folder, and in fact it's under Run Files, Demo Single, and here it is, the demo single dash or underscore 7238 input file. Once the file is loaded, we can then take a look at different parts of that file. In any given input file that's been generated by MapShed for a particular watershed, we can look at transport data, nutrient data, animal data if it exists, BMP data if it exists, something called delivery data, which we'll discuss later, as well as weather data. So let's take a look at the transport data. As discussed in a previous unit, MapShed is used to overlay, combine, and extract different GIS datasets for the purpose of estimating values for different input parameters used by the GWLFE simulation model. Some examples include percent impervious surface for urban land, curve number for impervious surfaces, curve numbers for pervious surfaces, curve numbers for different rural land categories, things like the K, LSCP factors that are used by the universal soil loss equation within the model to estimate upland erosion, and a number of other parameters. Now, it is beyond the scope of this basic tutorial to describe what each of these input parameter means, how they were generated, and how they're used in the simulation model. However, for those interested in such topics, discussions on these topics and others are provided in Section 3 of the MapShed User's Guide. Similar to transport data, MapShed has also estimated different parameters related to nutrient transport, such as dissolved runoff coefficients for different rural land use types, information pertaining to nutrient concentrations in groundwater, point source load if it's been provided. In our case, we did not provide a point source layer, but this can be edited if need be, and we'll discuss how to edit files in just a minute. Information on septic system populations has also been edited and so forth. We can also look at animal data. In this case, we did not provide any information on animals as part of our initial input to MapShed, but we can include numbers for different animal types here, and we will do that as part of this exercise in just a minute. We can also look at BMP data if it has been provided, which it has not at this point, but this is where we would edit the file to represent the implementation of different rural land and urban land BMPs. The input file also contains information on what's called delivery data, This data is a little involved. It is related to attenuation processes that can be considered by the model. We're not going to be doing that as part of this basic tutorial, but those interested in how attenuation is handled with the model can look at sections 2D and 2F in the MapShed User's Guide. If needed, we can even edit weather data that's been used by the model. We can do this by specifying a year and month, and then go in and edit actual temperature and precip information for any given day. Typically, this isn't done because we have to assume that the weather data is correct. However, it does happen that there are typographical errors that occur within a weather data set, and they may need to be fixed. And this is how one would do that. Again, this would typically not be done unless one was undertaking some kind of calibration, that is, matching observed versus simulated data for a given area, which we will not be doing, and which is not typically done as part of any given watershed assessment. Okay, so let's now go back and look again at some of the input data to see what we might want to edit or not. In the case of transport data, as described earlier, MapShed has come up with the best estimate for some of these values used based on the different GIS data sets used. Typically, we would not edit any of these values. Perhaps somebody has a better estimate of what the curve number value might be in a given area based on some engineering study. If that's the case, one could edit by just typing in a new value there. But I'm going to assume that, in most cases you would assume, that the data presented are the best estimates for transport data. So we would typically not edit that unless you have better information. In terms of nutrient data, it's possible that something is missing. For example, before, when we ran MapShed initially in this area, we did not provide a point source layer, and it could be that there's actually a point source discharge located within that watershed. If we know the loads and the amount of flow that's generated on a monthly basis, we could type that information in right here. For example, maybe we know there's 1,000 kilograms of nitrogen discharge per month on an average basis, and maybe 20 kilograms of phosphorus discharge, and that this might be at a volume of 1.2 million gallons per day. That's what MGD stands for, million gallons per day. And this might vary monthly. Perhaps we have the data, perhaps we don't. But if we do have that type of information, we can edit it here. For our purposes for this example, we're going to assume that we do not have the data and that these should all be set to 0. In fact, this might be the case if we're more interested in non-point source load for a given analysis. We probably don't need to enter the point source discharges, but if we do, that's how it's done. Now, in our case, we use the land use cover map to estimate septic system population. Maybe based on better information that's available locally, we have an estimate of maybe 1,200 people on septic systems. This is where we would enter that information again. So we'll just modify these previous estimates by typing in the new value right here. Once that's done, we will then say save file, and those edits are saved to that particular input file. Now, another example of information we typically don't have in any kind of GIS data layer is animal population information. And in some watersheds, the animal populations generate quite a heavy load, so it's important to account for these. So let's assume that in our case, in that small watershed, we have information on animal populations, and we can enter it here. So I'm going to say we have 75 dairy cows maybe 1,000 broilers or chickens, maybe 50 hogs. And when we type that information, other information is also applied to that number, such as the average weight, their typical loads per animal equivalent unit. There's lots of information pertaining to animal loads, and again, it's beyond the scope of this basic tutorial to describe these different factors, but suffice it to say that they have all been set at a reasonable default, and all we have to do is enter the animal population information here. For those interested in knowing about what these different values mean, and in fact this is a two-form input file or input operation for animal data. We have to provide data for both grazing animals and non-grazing animals, but again, these are already set by default. For those wanting to know more about these defaults, you can look at Appendix A in the MapShed User's Guide. So suffice it to say the defaults are reasonable. Once we've entered the animal population numbers, we can then save the file, and this information is saved. At this point, we can run the model again to see what these changes, what effects these changes have had on the load output. So for this particular example, I'm going to call the output file output2. You may recall that we had generated an output file called output1 in our initial model run in a previous unit. So using those saved input files with the new information, we then run the file again, and we have created a new output file that we can look at using this average output button, which is the typical output option you would use. So we'll hit that. We'll browse to the output folder. Again, it's output under the input folder, which in this case was demo single. So we'll go to output. You can see that we had a previous output 1 and now we have output 2. So let's look at the difference. So in output 1, I'll load that first. I will look at the load by source information, and I'll just focus on the phosphorus because that's at the end here. So if you look at this output on a mean annual basis in this watershed, the initial model run suggests that there is 1,307.1 kilograms generated in this watershed from the different sources indicated. So that's 1307.1. So now let's look at what the new model suggests based on the updated information. So I'll look at output 2. When I view that, again, I'll go to the loads by source, and that is now 1469.3. So we have increased that by the difference of 1469.3 minus 1307, I believe. So basically, about 160 kilograms per year have been added to the output. And the assumption is that the edited information is more reasonable or more accurate, and that's why we would edit data. Typically, we would not edit the input file unless we have better information. But if we have it, we want to account for it, and this is how it's done. Now, if we have BMP data, we can enter that here. For our purposes, we're not going to do this because we are going to do this kind of analysis in a later section. But what this particular function is for is to try to see what kind of effect different rural land and urban land BMPs have on a load generated by a particular watershed. And this comes into play when we're trying to plan for certain target reductions that might be required as part of a TMDL or MS4. And we will do that in Unit 8. So for now, this concludes the activities for Unit 6. With this final slide, I would like to summarize the basic modeling steps that one would utilize to estimate pollutant loads for a given watershed using the MapShed modeling tool. We would first run MapShed to create the input file for a given watershed. After the input file has been created, you could then open up the GWLFE model and edit or update the input file as necessary. Now this is listed as being optional because if there's no need to add new data or update the file providing information such as animal populations or septic system populations, then this step can be skipped and you can move directly to the third step, which is to run the GWLFE model to estimate pollutant loads and flows. So basically it can either be a 2 or 3 step operation. There are other optional steps that can be utilized depending on the need or situation. For example, one could edit the input file to better reflect transport, nutrient, and/or delivery parameter information, and this is usually only done if there's calibration being undertaken, or if it is known that there's better information that should be used. Typically, though, the input file does not have to be edited, and one could just do the 2-step operation as described above. Lastly, one could edit the BMP data in iterative fashion to evaluate various scenarios that could be implemented to reach target reduction goals. That is, one could generate an input file and then edit the input data pertaining to BMP implementation in an iterative fashion to see what scenario might be used to best reach a particular target goal. And this is an activity that will be discussed in a later section, in fact in Unit 8.